friends, this is the question number 2 for the miscellaneous exercise for the application of derivatives. If the curve ax square plus by square is equals to 1 and a dash x square plus b dash y square is equals to 1 intersect orthogonally, then prove that 1 upon a minus 1 upon b is equals to 1 upon a dash minus 1 upon b dash. Now we have the curves, that is ax square plus by square is equals to 1. This is the equation number 1. A dash x square plus b dash y square is equals to again 1. This is equation number 2. Now we will differentiate this with respect to x. That is the derivative of x square, that is a 2ax, and derivative of y square is a 2y into dy by dx, that is a 2by into dy by dx is equals to 0. Therefore, using this we will find out the value of the dy by dx. This is the implicit type of the derivatives. Dy by dx is equals to minus ax upon by. And the next is a dash x square plus b dash y square is equals to, that's I think that it is 1. By mistake I have written there as a 0, but it is the 1. Okay, I will write here 1. Okay, it is a 1. Differentiate this with respect to x, and the derivative of x square is again, that is a 2a dash x plus y square is again that is a 2b dash y into dy by dx is equals to 0. Therefore, dy by dx is equals to minus a dash x upon b dash y. As the curve intersect orthogonally, that is a tangent at the points are perpendicular, means the tangent drawn to the curves are perpendicular to each other. It's clear that the product of their slope that is equals to minus 1. What is the slope of the first curve? That is a minus ax upon by. This is the first slope, and the second slope is a minus a dash x upon b dash y. Now the product of these two slope is a minus 1 minus ax upon by into minus a dash x upon b dash y, that is equals to minus 1. And if we simplify this, that is a into a dash b upon b into b dash x square upon y square, that is equals to minus 1. Now we'll consider the equation, these two equations. If we consider that ax square plus by square is equals to 1 and a dash x square plus b dash y square, that is equals to 1. Equation number 1 minus equation number 2. Then we will have, that is a minus a dash x square plus b minus b dash y square, that is equals to 0. Therefore, x square upon y square, if we simplify this, and that is equals to minus in bracket b minus b dash upon a minus a dash. And if we substitute the value of this x square upon y square in this equation, then we will get the required proof. Therefore, a up into a dash upon b into b dash into minus in bracket b minus b dash upon a minus a dash, bracket complete, that's equals to minus 1. Therefore, a dash in bracket b minus b dash is equals to b dash in bracket a minus a dash. And if you simplify this, then you will get a dash b minus a dash b dash, and that is equals to b dash a minus b dash and a dash. Now dividing the throughout the equations, what is that a dash and b dash throughout this equation, then you will get, that is a dash b upon a dash b dash minus a dash b dash upon a dash b dash, that is equals to b dash a upon a dash b dash minus b dash a dash upon a dash b dash. And if we simplify this, then you will get 1 upon b dash minus 1 upon b, that is equals to 1 upon a dash minus 1 upon a. And if we rearrangement of the terms, that is a minus 1 upon a to the left hand side, then the required equation, that is 1 upon a minus 1 upon b is equals to 1 upon a dash minus 1 upon b dash. And this is we want to prove. Now see this here. The curves ax square plus by square is equals to 1 and the a dash x square plus b dash y square is equals to 1 intersect orthogonally, means the tangent drawn to that curves are perpendicular to each other. Then prove that 1 upon a minus 1 upon b is equals to 1 upon a dash minus 1 upon b dash. Now we'll find out the dy by dx for these two curves. Ax square plus by square, that is equals to 1, and a dash x square plus b dash y square, that is equals to 1. Now differentiate these two. First equation, that is dy by dx is equals to minus ax upon by. And the second equation, a dash x square plus b dash y square, that is equals to, again here is I written 0 but there is a 1. Therefore dy by dx is equals to minus a dash x upon b dash y. As the curves intersect, orthogonally, tangent at that point are perpendicular. And therefore product of their slope is minus 1, minus ax upon by into minus a dash x upon b dash y, that is equals to minus 1. Therefore a dash into x square upon b dash upon y square, that is equals to minus 1. Now we'll here find the values of x square upon y square by solving these two equations. That is ax square plus by square is equals to 1. A dash x square plus b dash y square, that is equals to 1. If we subtract, then you will get a dash into x square plus b minus b dash into y square, that is equals to 0. X square upon y square is equals to minus in bracket b minus b dash upon a minus a dash. So there we will substitute the values. That is put in equation number 3, that is a into a dash upon b into b dash into minus in bracket b minus b dash upon a minus a dash, that is equals to minus 1. Therefore a dash in bracket b minus b dash is equals to b dash in bracket a minus a dash. Therefore a dash b minus a dash b dash, that is a b dash a minus b dash a dash. Dividing the throughout this equation, that is a dash b dash. Therefore, we'll get 1 upon b dash minus 1 upon b is equals to 1 upon a dash minus 1 upon a. Rearrangement of the terms, bring this minus 1 upon a to the left hand side, it becomes 1 upon a minus 1 upon b is equals to 1 upon a dash minus 1 upon b dash. Hence, it is a truth. Now, the next is question number 2. Determine the area of the triangle formed by the tangent to the graph of the function, that is y is equals to 3 minus x square, drawn at the point 1, 2 and the coordinate axis. That is, first of all, we will find out the equation of the tangent to the line y, to the curve, that is y is equals to 3 minus x square. At the point, that will be the equation of the line. When that line touches the coordinate axis, the triangle will be the formation of the triangle, and we will find out the equation of that is the area of the triangle. Now, first of all, y is equals to 3 minus x square. Differentiate this with respect to x. dy by dx is equals to minus 2x. Therefore, dy by dx at x is equals to 1. That is equals to minus 2 into 1. That is equals to minus 2. This is the slope of the tangent at that point, which is 1, 2. Now we'll form the equation of the tangent. Now we have the slope that is equals to minus 2. Now see this here figure. This is the x-axis, y-axis, and this is the tangent. Now the equation of the tangent, that is the y minus 1. First of all, we form the equation, then we see this coordinate axis. Y minus y1 is equals to m in bracket x minus x1. We have given the points, that is the points are 1 and 2. Therefore, y minus 2 is equals to minus 2 in bracket x minus 1. Y minus 2 is equals to minus 2x plus 2. Therefore, 2x plus y is equals to 4. This is the equation of the tangent. Now, we want to find out the triangle formed by this line and the coordinate axis. If you see this, when this line touches the x-axis, then y is equals to 0, then 2x is equals to 4. Therefore, x is equals to 2. Therefore, the line touches this point. And when it touches the y-axis, x is equals to 0 and y is equals to 4. And that's why the point is 0, 4. Now, here is a triangle AOB. Now, we want to find out the area of the triangle. It's clear that these two lines are perpendicular and this is the base and the height. 2 into 4 into 1 upon 2, that is the area of the triangle, that is equals to 4. Again, see this. First of all, what we have done, we find out the equation of the tangent to the given curve at the point 1, 2, differentiate it, find out its slope, equation of the tangent, and then we draw this figure. That is, this is the line when it touches the x-axis, the coordinate is 2, 0. When it touches the y-axis, the coordinate is 0, 4. And we can determine this area of the triangle. See this again. Question number 2. Determine the area of the triangle formed by the tangent to the graph of the function y is equals to 3 minus x square drawn at the point 1, 2. And the coordinate axis. Now y is equals to 3 minus x square. Differentiate this with respect to x. Therefore, dy by dx is equals to the derivative of 3, 0 and x square is a minus 2x. And it's a derivative at x is equals to 1, that is a minus 2 into 1, that is equals to minus 2. This is the slope of the tangent to the curve at 1, 2. Now equation of the tangent, that is y minus y1 is equals to m in bracket x minus x1. Y minus 2 is equals to minus 2 in bracket x minus 1. Y minus 2 is equals to minus 2x plus 2. Therefore, 2x plus y is equals to 4. This is the equation of that tangent. Now we want to find out the area of this line and the area formed by this line and the coordinate axis. X-axis and y-axis. Now when this line touches, these are the point of intersection with the coordinate axis. Therefore, area of triangle is equals to 1 upon 2, 2 into 4. This distance is 2, OA, and the OB is 4. Therefore, area of the triangle is equals to 4. This is the area. Now, next, find the equation of the tangent and the normal to the curve y raised to 4 minus 4 x raised to 4 minus 6xy is equals to 0 at the point M1, 2. Now, this is the equation of the curve. Now, differentiate this with respect to x. Implicit type of this function y raised to 4, that is a 4y cube into dy by dx minus 16x cube minus 6 in bracket derivative of x into y. Now here we will apply the product rule. Derivative of x is 1 into y plus x into dy by dx, that is equals to 0. Now at the point 1, 2, now we will find out its a value. Put x is equals to 1 and y is equals to 2. If we substitute, then you will get x is equals to 1 and y is equals to 2. Then we will get the, that is a 4 into 2 raised to 3 into dy by dx minus 16 into 1 cube minus 6 in bracket 2 plus 1 into dy by dx is equals to 0. That is 4 into 8 into dy by dx minus 16 minus 12 minus 6 into dy by dx is equals to 0. Collect the term of the dy by dx and the numbers. This is the 32 dy by dx minus 6 dy by dx minus 28 is equals to 0. Therefore, 26 dy by dx is equals to 28. Therefore, dy by dx is equals to 14 upon 13. Now the equation of the tangent, that is the y minus y1 is equals to m in bracket x minus x1. That is y minus 2 is equals to 14 upon 13 in bracket x minus 1. And if we simplify it, that is a 13 in bracket y minus 2 is equals to 14x minus 14. And therefore 13y minus 26 is equals to 14x minus 14. Therefore 14x minus 13y plus 12 is equals to 0. This is the equation of the tangent. Now the equation of the normal. Now what is the slope that we get? That is a 14 upon 13. Therefore the slope of the normal is minus 1 upon m. That is a minus 13 upon 14. Therefore the equation of the normal is y minus 2 is equals to minus 13 upon 14 in bracket x minus 1. And if we simplify it, that is a 14y minus that is a, if we multiply it with the 14, that is a 14y minus 28. Here is a 28 because due to this my pen, there is a 2 is absent there. That is a 14y minus 28. That is equals to minus 13x plus 13. And if we simplify this, then you will get 13x plus 14y minus 41 is equals to 0. This is the equation of the normal. Now see this again. Find the equation of the tangent and normal to the curve y raised to 4 minus 4x raised to 4 minus 6xy is equals to 0 at the point M12. Now y raised to 4 minus 4x raised to 4 minus 6xy is equals to 0. Now differentiate this with respect to x. 4y cube into dy by dx minus 16x raised to 3 minus 6 in bracket x into y. Derivative of x is 1 into y plus x into dy by dx, that is equals to 0. And at the point M12, x is equals to 1 and y is equals to 2. Four into 2 raised to 3 into dy by dx minus 16 in bracket 1 raised to 3 minus 6 in bracket 1 into 2 plus the value of x is 1 into dy by dx, that's equals to 0. Now simplify this. That is 4 into 8 into dy by dx minus 16 minus 12 minus 6 into dy by dx is equals to 0. Therefore 32 dy by dx minus 6 into dy by dx minus 28 is equals to 0. Therefore 26 dy by dx is equals to 28. Therefore dy by dx is equals to 14 upon 13, that is a 28 upon 26. This is the slope of the tangent. Now the equation of the tangent, that is y minus y1 is equals to m in bracket x minus x1. Y minus 2 is equals to 14 minus 13 in bracket x minus 1. 13 in bracket y minus 2. 14x minus 14, that is 13y minus 26 is equals to 14x minus 14. Therefore, 14x minus 13y is equals to or simplify it, that is 14x minus 13y plus 12 is equals to 0. This is the equation of the tangent. Now the equation of the normal, y minus y1 is equals to minus 1 upon m in bracket x minus x1. Y minus 2 is equals to minus 13 upon 14 in bracket x minus 1. If we simplify it, 14y minus 28 is equals to minus 13x plus 30. Therefore, here the equation of the normal is 13x plus 14y minus 41 is equals to 0. Now here is a 2 is the correct one. This is the equation of the normal. Now the question number 4. A water tank in the form of an inverted cone is being emptied at the rate of 2 cubic. Now I will again repeat this problem. A water tank in the form of an inverted cone is being emptied at the rate of the 2 cubic per second. The height of the cone is 8 feet and the radius is 4 feet. Find the rate of change of the water level when the depth is 6 feet. Now here, see this the triangle. This is the tank. It is in the form of the inverted cone. And this is the height. Total height is 8 feet. The radius is 4. We want to find out the rate of change of the water level when the depth is 6 meter. Okay. Therefore, now see this triangle. That is a triangle ABC. And the second triangle, that is the ADE. Now here is a triangle ADE, ABC, ADE. Now these two triangles are similar. Therefore, their corresponding sides are in proportion. That is the BC upon DE is equals to AB upon AD. Now we know the values of BC, that is a 4, and the DE is R. We have treated it at that moment. Again, AB is equals to 8, and that is a total height of perpendicular height, and the AD, that is at that moment, that is the H. Therefore, we have the 1 upon R is equals to 2 upon H. Therefore, R is expressed in terms of H. R is equals to H upon 2. dV upon dH is equals to, that is a 2 cubic feet per second. Now we have given this, that is a water tank is emptied at the rate of the 2 cubic feet per second. Therefore, dV upon dt is equals to 2 cubic feet per second. Now what is the volume of the cone? This is in the form of the cone. Therefore, V is equals to 1 upon 3 pi R square into H. Now here we will substitute the value of the R, which is H upon 2. Therefore, this equation will be in the form of, the volume is in the form of the H. That is 1 by 3 pi H R square. That is R is H upon 2, that is H square upon 4. that is equals to 1 by 4 into 1 by 4 into pi h cube. That is V is equals to 1 by 12 pi h raised to 3. Now differentiate this with respect to t. dv upon dt is equals to 1 upon 12 pi 3h square into dh upon dt. Therefore, the water is empty at the rate of, that is the, we have given it, it is a 2 of cubic feet per second. And that's why we are substituting that is equals to 2. Therefore, it is a, if we simplify it, then we'll get that is a dh upon dt. Therefore, the height is reducing at the rate of, therefore, if we substitute dv upon dt, that is a 2, that is equals to 1 by 4 pi into 36 into dh upon dt. Therefore, dh upon dt is equals to 2 upon 9 pi. And at this rate, the height is decreasing. Now see this again here. A water tank in the form of an inverted cone is being emptied at the rate of 2 cubic feet per second. The height of the cone is 8 feet. And the radius is 4 feet. Find the rate of change of by mistake there is a L. Find the rate of change of water level when the depth is 6 feet. CHANGE. My mistake, there is a, okay. Now see this here. That's why I have seen that the triangle ABC and the triangle ADE. These two triangles are similar. I will show you figure. As these two triangles are similar, therefore BC upon D, AB upon AD. Now here are the dimensions. That is the BC is a 4 and the AB, that is the 8 feet. D, that is the radius, is equals to 4. Next is AD, which is the height when the water is in the cone. Therefore, 1 upon R is equals to 2 upon H, and therefore R is equals to H upon 2. Now we have given that the water is empty at the rate of 2 cubic feet per second. and we want to find out at what rate that is the rate of change of its depth. That is, we want to find out dv upon dh. V is equals to 1 upon 3 pi r square into h. This is the figure. You can see this here also. Next is 1 upon 3 pi r square into h. Substitute the values. That is 1 by 3. The value of r is h upon 2. That is a h square upon 4. 1 by 3 into 1 upon 4 pi h cube. That is 1 upon 12 pi h cube. Now differentiate this with respect to t. dv upon dt is equals to 1 upon 12 pi 3h square dh upon dt. Now here we will substitute the value of dv upon dt. That is 1 by 4 pi h square into dh upon dt. We treated it here as the 2 because we want to find out only its rate. Yes. It's treated as only the 2. That is 1 by 4 into pi 36 into dh upon dt. That is, I am writing here, which is a 2 by mistake. It is a, or you may also treat it as like this. That is, the water level is decreasing at this rate. It means we write in terms of in positive number. Therefore, dh upon dt is equals to therefore dh upon dt is equals to 2 upon 9 pi feet per second. At this rate, it is a decreasing. That's why minus sign, but we write here as answer as a positive. Now the next is question number 5. Find all the points on the ellipse 9x square plus 16y square is equals to 400 at which the y coordinate is decreasing and the x coordinate is increasing at the same rate. Okay, therefore we will find out decreasing and the x coordinate is increasing. Now we have the given equation of the ellipse 9x square plus 16y square is equals to 400. Differentiate this. This is implicit type of the parametric differentiation. That is a 9 into 2x into dx upon dt. Therefore 16 plus 2y into dy by dt, and that is equals to 0. Therefore 18x into dx upon dt is equals to minus 32y into dy by dt. We'll find out the value. That is, one is a decreasing and another is a increasing, but their rate is the same. Therefore, we will substitute here dy by dt is equals to dx upon dt. Instead of dy by dt, we will write here dx upon dt. and on the both sides these two get cancelled, and therefore y is equals to 18x upon 32 is equals to 9x upon 16. This is the value of the y. Therefore 9x square plus 16y square is equals to 400, and substitute the value of the y, that is a 9x square plus 16 in bracket 9x in bracket 9x upon 16 bracket square is equals to 400. And if we simplify this, that is a 9x square plus, here is a 16 into 9 square upon 9 square into x square upon 16 square. That is, we will get 81 x square upon 16, that is equals to 400. And if we simplify this, then you will get 9x square into 16 plus 81 x square, that is a 400 into 16. If we take x square as a common, then in that is, or we can add this, that is 144 plus 81 is equals to 400 into 16, that is a x square into 225 is equals to 400 into 60. If we simplify it, then you will get 400 into 16 upon 225, that is equals to 16 upon 3 bracket square. Therefore x is equals to plus or minus, if we take the square root, that is a 16 upon 3. If we substitute the value of the it's a plus or minus, then you will get also y is equals to, that is 9x upon 10, 9 upon, sorry, here it's a 16 here, 9 upon 16 plus or minus 16 upon 3. And therefore this 16 get cancelled, and you will get y is equals to plus or minus 3. And therefore when x is equals to 16 upon 3, then y is equals to 3. And when x is equals to minus 16 upon 3, y is equals to minus 3. These are the points. Now this is treated as the same rate, not the same time. Find all the points on the ellipse. Nine x square plus 16y square is equals to 400, at which y coordinate is decreasing, and the x coordinate is increasing at the same time. Not this time, but it is treated as the rate. Now differentiate this first equation, that is a 9x square plus 16y square is equals to 400 with respect to x. The derivative of x square is a 2x into dx upon dt plus 16 into 2y into dy by dt is equals to 0. Therefore 18x into dx upon dt is equals to minus 32y into dy by dt. Now it's a changing at the same rate. Therefore dx upon dt is equals to dy upon dt. We'll substitute the value. We are writing here, again I am repeating here, here is a not same time, it is a same rate. Therefore I had written here. Therefore the value of the y is 18x upon 32 is equals to 9x upon 16. If we substitute the value of the y in this equation, that is a 9x square plus 16y square is equals to 400. Therefore you will get 9x square plus 16 in bracket 9x upon 16 bracket square is equals to 400. Therefore 9x square plus 16 into 9 square x square upon 16 square is equals to 400. Therefore 9x square plus 81x square upon 16 is equals to 400. That is a 9x. If we simplify it, 9x square into 16 plus 81, x square is equals to 400 into 16. And if we add it, that is a x square in bracket 9 into 16. That is 144 plus 81 is equals to 400 into 16. Therefore, x square into 225 is equals to 400 into 16. Therefore, x square is equals to 400 into 16 upon 225. If we simplify it, then we will get x square is equals to 16 upon 3 bracket square, and x is equals to plus or minus 16 upon 3. Y is equals to 9x upon 10. We substitute the value of the x, that is a y is equals to 9 upon 16 in bracket plus or minus 16 upon 3. Then you will get the value of the y, that is equals to plus or minus 3. Therefore, when x is equals to 16 upon 3, y is equals to 3, and x is equals to minus 16 upon 3, y is equals to minus 3. And hence the answer is 16 upon 3, 3, and minus 16 upon 3, minus 3. Question number 6. Verify Rolle's theorem for the function f of x is equals to 2 upon e raised to x plus e raised to minus x on the closed interval minus 1 to 1, minus 1 and 1. Now for the Rolle theorem, that is Rolle's theorem, that is the function is a continuous on a closed interval and the differentiable on the open interval, whatever that given. And also we have, that is the f of 1 is equals to f of minus 1. This is the Rolle's theorem. Or you may have the pronunciation as you like. Now the given function f of x is equals to 2 upon e raised to x minus e raised to minus x is a continuous on the closed interval and the differentiable on the open interval minus 1, 1. That is the one more condition is important, that is f of 1 is equals to f of minus 1 and f dash of c is equals to 0. Now the value of f of minus 1, if we substitute x is equals to minus 1, then you will get 2e upon 1 plus e square. Okay, simplify this. That is x is equals to plus 1, and when x is equals to minus 1, then again you will have, that is a 2e upon 1 plus e square. Now these two values are equal. Thus f satisfies all conditions of Rolle's theorem. Now there exists C belongs to in closed interval, that is C belongs to open interval -1 to 1, such that f dash of C is equals to 0. Now the given function f of x is equals to 2 upon e raised to x plus e raised to minus x. F dash of x is equals to 2 upon e raised to x plus e raised to minus x bracket square into ddx of e raised to x plus e raised to minus x, which is e raised to x minus e raised to minus x. It's a bracket square. Therefore, the f dash of c, that is 2 into in bracket e raised to c minus e raised to minus c upon e raised to c plus e raised to minus c bracket square, that's equals to 0. And again, if we simplify, that is e raised to c minus e raised to minus c is equals to 0. And you will have e raised to c is equals to e raised to minus c, which is equals to e raised to 2c. If we simplify this, that is equals to 0. Therefore, 2c is equals to 0 and this c is equals to 0, and which belongs to that open interval -1 to 1. Hence, Rolle's theorem is verified. Verify the Rolle's theorem for the function f of x is equals to 2 upon e raised to x plus e raised to minus x on closed interval -1 to 1. Now given function f of x is equals to 2 upon e raised to x plus f of x is equals to 2 upon e raised to x plus e raised to minus x is a continuous on closed interval 1 -1 1 and differentiable on open interval -1 1. Now the f of x is equals to 2 upon e raised to x plus e raised to minus x. The value of f of 1, that is a 2 upon x, is replaced by 1. That is a 2 upon e plus e raised to minus 1. And if we simplify this, then you will get 2e upon 1 plus e square. F of minus 1 is equals to, that is x is replaced by minus 1. That is a 2 upon e raised to minus 1. And this minus minus will become plus 1. And therefore you will get, that is a 2e. If we simplify this, it becomes plus. That is a 2e upon 1 plus e square. Now these two values are same. Therefore the f of minus 1 is equals to f of 1. Thus the f satisfies the condition. Now the Rolle's theorem of the Rolle's theorem. Now there exists a c belongs to the open interval -1 to 1 such that f dash of c is equals to 0. F of x is equals to 2 upon e raised to x plus e raised to minus x. F dash of x is equals to, it's a derivative, that is a 2 upon e raised to x plus e raised to minus x bracket square into ddx of e raised to x plus e raised to minus x, which is e raised to x minus e raised to minus x. Therefore the f dash of x is equals to 2 in bracket e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x bracket square. Therefore the f dash of c is equals to 2 e raised to c minus e raised to minus c upon e raised to c plus e raised to minus c bracket square, that's equals to 0. And if we simplify this, then you will get, that is this becomes 0. Then that is e raised to c minus e raised to minus c is equals to 0. Therefore e raised to c is equals to e raised to minus c. That is e raised to c is equals to 1 upon e raised to c. E raised to 2c is equals to 0. It means that the value of that is equals to 1. Therefore the value of the 2c must be 0. That is e raised to 0 is equals to 1. That's why 2c is equals to 0. Therefore c is equals to 0, and which belongs to the open interval minus 1 to 1, and hence the Rolle's theorem is verified. Now the next is, it is the question number 7. The position of a particle is given by the function s of t is equals to 2t square plus 3t minus 4. Find the time t is equals to c in the interval where the values of the t lies between 0 to 4. That is that it's equals to 0 and equals to 4 also. When the instantaneous velocity of the particle equals to the average velocity in this interval. Now the average velocity is equals to delta x upon delta t, which is x4 minus x0 upon t4 minus t0. Now we have the equation, that is st is equals to s is equals to 2t square 3t minus 4, and the value of x4, that is x is replaced by 4, then you will get, that is a 2 into 4 square plus 3 into 4 minus 4, that is equals to 32 plus 12 minus 4, that is equals to 40, and x0 is equals to 2 into 0 plus 3 into 0 minus 4, which is equals to minus 4. Therefore the V average, that is equals to x4 minus x0 upon t4 minus t0, that is 40 minus in bracket minus 4 upon 4 minus 0, which is 44 upon 4, that is equals to 11. The instantaneous velocity is equals to ds upon dt. That's we are differentiating this, which is the 4t plus 3. Therefore the ds upon dt at c, that is a t is replaced by c, that is a 4c plus 3. The instantaneous velocity is equals to the average velocity, that is equals to 4c plus 3 is equals to 11. Therefore the 4c is equals to 11 minus 3, that is equals to 8, and therefore c is equals to 8 upon 4, which is equals to 2. This is the value of the c. Now see this again here. The position of a particle is given by the function s of t is equals to 2t square plus 3t minus 4. Find the time t is equals to c in the interval where the values of t lies between 0 to 4, when the instantaneous velocity of the particle equals to its average velocity. In this interval, average velocity we will find out, and instantaneous velocity, that is the derivative of s, and instantaneous velocity, that is the uh, average velocity, that is the delta x upon delta t is equals to x4 minus x0 upon t4 minus t0. The value of s is equals to 2t square plus 3t minus 4. x4 is equals to, that is the t is replaced by 4, 2 into 4 square plus 3 into 4 minus 4, that is equals to 32 plus 12 minus 4, that is equals to 40. x0 is equals to, that is equals to minus 4. Therefore, the V average is equals to 40 minus in bracket minus 4. I had changed there. That is 44 upon 4. That is equals to 11. The instantaneous velocity, that is a ds upon dt, is equals to 4t plus 3. At t is equals to c, that is 4c plus 4. Instantaneous velocity is equals to the average velocity. That is a 4c plus 3 is equals to 11. And 4c is equals to 11 minus 3. That is equals to 8. Therefore, c is equals to 8 upon 4. That is equals to 2. Therefore, c is equals to 2. And in this way, we have completed up to the question number 1 to 7. Now we'll see in the next video. Till then, goodbye.